Good morning, good afternoon, good evening for anybody, wherever you are in the world. Welcome to the CCS33 webinar. And we're going to give a little bit of time for the attendees to settle in. And we are seeing the numbers increasing. And as you know, the Zoom session takes a little bit of time until it gets completely settled. And also we are going to give a little bit of time for the people to join in case that they have been missing the invite. In the interim, just a reminder, we're going to talk about the value of CCS33 for solving the live streaming challenges, and also the limitations of border gateway protocol for the live content delivery, and how both elements relate to each other. For those of you that have attended the Streaming Media Connect conference last week, you may have seen some of this information on the beginning of the talk, but we're going to get deeper on the really interesting stuff. We will have more time here to go deeper into the technical details. And we're going to also provide new content and new information that was not shown on that talk. And in any case, regardless of being attending this call, the previous one, or during this call, you would like to have more questions, we will have also the chance to do a Q&A at the end of the talk, and we also give you some more logistical data along those lines. Remember, we're using the Q&A section of the Zoom platform for delivering the questions. Please do not use the chat because we monitor the Q&A panel only for the questions, and if you have any doubts during the talk or at the end, do not hesitate to send a question over there, and both my team and I will be monitoring them, and we will be answering on air during the middle of the talk if the time is suitable, or at the end of the talk because we have a dedicated section over there. Okay, we have a couple more attendees coming by. It's a good attendee, so we're going to wait a couple of minutes until that is settled. And in the interim, I want to just set up the screen, share it with you, and give you some more information that is worth sharing. So bear with me while I set this up, and I will share this with you guys. Okay, so you should be able to see my screen. I request my helpful team in marketing to reach out to chat to confirm that they are seeing the screen so we can move on. And in the interim, I will share with you some information in case that you would like to see more about this content, more about these details that we have been talking about into the face-to-face environment. So we are be able to discuss these elements with you if you are able to attend the IBC conference next week in Amsterdam. We will be there. We will have a booth over there as usual. We will be able to connect with you guys if you are able to attend. So do not hesitate to scan the QR code if you want to schedule a slot with us. Do not take too much time because the agenda is already pretty packed, but we will have some free slots still remaining. Do not hesitate to ping us, and you will see the form to reach out to us and be able to see our services and also meet us face-to-face in Amsterdam next week. The floor opens on the Friday, I think, at 9th, and we will be there for almost 1 week. And in any case, if you still have some questions that would like to be answered, again, we will have the Q&A section at the end of the talk. Please use the Q&A section of the Zoom interface. Do not use the chat, and we will cover them over there. Let me check how the attendees filling up is settling. I think we are in a good position. And with this, I think we can comment. Again, this QR will be available at any point in time on the top left side of the slides. So if you're interested, just scan it out right away, and we will be able to schedule a meeting with you guys. Okay, so for those that had attended the Streaming Media Connect conference last week, but even if you are not, we're going to give you an introduction just to settle the ground. This part is similar to that talk, but it's relevant because we need to set the scenery of what we are going to talk about. And at the end of the day, it's relevant to have the context in place. First of all, what we want to deal with here is what we all in the industry are aiming for, that is provide the best quality of experience for our audience, and specifically in live streaming events at scale. But of course, if we are in this industry, it's because there are no silver bullet for the problems, and we need to find solutions for those problems. And most of the common issues that we need to confront will be introduced at the beginning. Then we're going to go into how to have the full visibility of the delivery chain, because that's really important in order to solve this problem. With that information, then we can go into setting up the stage for the optimal delivery. And at the end of the day, we will unlock the full potential of the delivery network. Okay, so let's dive right in. Common issues with live streaming workflows. At the end of the day, whenever you have an issue with a live stream event, it's usually because there's something going on with the quality of experience for your audience, right? And it's not only that there's something going on with the quality of experience, it's just the fact that you don't have control for that quality of experience changes, and you need to do something about that, right? At the end of the day, we need to have a solution for the problems that avoid us to have the top-notch quality. So the things that are related with that are usually limitations on the network infrastructure. So it can be anything along the way, from the origination through the traditional CDNs, through the peering points, the last mile. It can be any place along the delivery chain, but it's usually some kind of limitation on the network infrastructure. And sometimes those limitations do not show up right away. They only show up potentially on prime time, whenever you have the all audience coming by at the same time, when everything was primed for this large event that you are looking forward. And then is when the issues start to rise because you don't have a way to replicate that. Or sometimes it's just an organic event that happens on your linear stream, on the 24/7 content that you're delivering, and you cannot forecast that, but at the end of the day, the outcome is the same. The amount of traffic that comes by to your content means that the saturated points of the delivery become a congestion point, right? You have a lot of traffic going through the internet, and at the end of the day, wherever there is a bottleneck on the delivery chain, that is going to impact the quality of experience. Again, doesn't have to be points necessarily on the last mile. It can happen on the middle mile, and it can also happen all the way back to the origin server if you have a lot of requests coming by. And the outcome, of course, is that you have audience churn. So whenever there is quality of experience impact, the audience leave. This is a very, very direct relationship between quality of experience and audience retention. And even the simple changes in the quality, not necessarily a rebuffering event, is going to create that impact. If you are watching a content and you expect top-notch quality because that's what you're used to based on the competition, if you see that the quality of experience in terms of quality, the video, the bit rates, things along those lines change, then it's going to have an impact too. Okay, so this is what we're talking about here, and we need to move forward to find a solution for this. And in order for doing that, we're going to go back to the basics. We're going to settle what is the very basis of what we are doing in our industry, that is essentially delivering content for live and linear events. And we're going to start with the basics about what is the usual delivery workflow for video in live. So here in this slide, we will have just a simple scenario, maybe not the most simple because we have a couple of CDNs, but at the end of the day, we will have content that is encoded in multiple different renditions or bit rates or resolutions. So all the way from 480 or even lower up to 4K or even higher, with different qualities in between, right? The content is made available, is going to be delivered to your audience whenever the event starts, or if you're in a 24/7 event, whenever the content is consumed. And you may have one CDN, multiple CDNs, or a combination of single CDN with an expansion of the delivery network, you name it. At the end of the day, you have an infrastructure that is in charge of making the content arrive from your origins into your audience. And that traverses open internet infrastructure most of the time. That is showcased here with this box below the CDNs and the connections between the audience and the origins across that board. And here we're just showcasing that sometimes something happens during those events that you may or may not have any visibility about, but many, many times you don't have control about it. For example, here you may have the content with a single CDN, but the amount of audience that is coming is creating an impact on the network links. And from this point onwards, maybe the capacity of the network from this point into the audience is not enough. It can be anything. It doesn't have to be anything related with the CDN itself. It can be peering points that connect the CDN with your ISP, can be saturated last mile, you name it. At the end of the day, you have an area of congested network that makes your content lower in quality. So for ATP in this case, you may have other areas of the network that are not so bad, like here in the top, or some of them that are actually working correctly. And this is an example with three CDNs, but at the end of the day, it doesn't change the topic. You can have these scenarios with one or multiple. It doesn't change the fact at the end of the day. Even if you choose the right path for these guys, maybe these guys is not suitable for covering everything. So what we want to showcase here is that this is the very basic workflow, and there are issues that happen during the event, even if you have multiple CDNs at the same time. So how we solve this problem? Okay, let's go back even further into the basics. We are going to have a conversation about what is the first principles that are required to make live events scalable and working with good quality. And if you have looked closely here, you will see here that there is a path here in green that goes all the way from the origin into one of the CDNs. Doesn't matter until it reaches the audience. And here it creates kind of a tree, a fork of the content, because it's being delivered to a plethora of devices. Okay. At the end of the day, it doesn't change anything. If it's good or bad experience, you will have this kind of workflow. And essentially, that is a broadcasting tree. Okay. So let's build that broadcasting tree. At the end of the day, that's what we are all aiming to do, making the content come from a source point, the root of the tree, into the leaves of the tree that is your audience. Why am I referring to this? Because all of us may recall the days when we were just consuming content, flipping up a switch in the TV, and we were receiving the content through either terrestrial, satellite, or cable, and it just worked, right? You didn't have a rebuffering event on those scenarios. Unless somebody was tampering with the cable or just violating the radio frequency laws, you were getting the content, right? So what we want to achieve is that user experience at scale in the new medium that is on OTT, over the open internet. So at the end of the day, nothing changes from the first principles perspective. What you had as an experience at that point in time when you were flicking up the TV and you're watching content through the terrestrial, satellite, or cable, what you had is a content that was coming from somewhere, radio station, TV station, you name it, and then it went through an infrastructure that at the end of the day was just a sequence of relaying mechanisms. In case of terrestrial TV, so the TV stations, the antennas were the relaying mechanism. TV stations sent the content to the antenna propagated that to the audience. It's a fan-out architecture. It's a tree at the end of the day, because every time that it reaches a node in the middle, it fans out into multiple. The same applies for cable. Just to break up boxes. In the case of satellites, the same applies. You have the satellite, and the satellite is a broadcasting fan-out tree in that regard. And in OTT, we have the same kind of possibilities to do it the right way, but we need to do it the right way. And here the challenge comes, of course, from the change in the medium. So with the scenery setup, we are going to have the broadcast tree as a first principle technology or setup or arrangement topology at the end of the day in terms of networking to make the content arrive at scale and with good quality to your audience. And here we're going to talk about with the concept of peer-to-peer network, because at the end of the day, even if you're using traditional CDNs, the concept of a peer is still there. We're going to talk about a little bit of that later on, but let's say, for example, that you have a single CDN, traditional setup, you have a node that is ingesting the content from your origin here on the top side of the diagram, and then you have the CDN POPs inside the ISP's network or just spread out across the world. At the end of the day, the actual hardware devices that are relaying the content from this place to this place are just computational devices, servers, points of presence, racks, you name it. They are just computers in one area of the network. And their role is to relay the content from this point in place to the next one in a fan-out architecture. Fair enough. If you're using a little bit more advanced setup with an expansion of the CDN capacity with end-user devices, like one of our portfolio of services that is Edge Intelligence, we are able to do so with leveraging the end-user devices capacity. But at the end of the day, it doesn't change whatsoever from this first principles approach. You have computational devices here that are capable of relaying content to somebody else. And here, just for the sake of having a whole picture, you may have fixed devices, or you may have mobile devices, especially if you are taking into account the end user devices, but doesn't change. At the end of the day, they are just members of this tree that are interested on the content or interested on relaying the content, or sometimes both. So, okay, this is what we want to do whenever we are delivering content to anybody else, but then when the reality kicks in, things start to happen, right? So what reality kicks in means that the infrastructure underlying this tree is the actual physical connections on those network devices and the internet service provider that traverse those network links. So in this very toy example, but it's still visually compelling, we have the devices either from the CDN or from the audience working on top of an infrastructure that is the internet service providers, either on the last mile or on the middle mile or in the backbone, doesn't matter. You have providers underneath that are providing the infrastructure for the routers and the links between them to make the content traverse the open internet. And you will have at the end of the day, well, some nodes here in the infrastructure of the CDN, for example. Some nodes will be embedded into the ISP because they are part of the audience itself, or some nodes may be part of the CDN because they are actually embedded inside the ISP, but with a rack, with a point of presence. It doesn't change. The fact is that in order to make the content be delivered fine to your audience, you need to traverse these interfaces here between those ISPs. And this is really important because whenever something happens, especially in large live events, and the congestion starts to appear, we need to understand where that issue is. So let's say, for example, that we start with this large event, and then we have this abstraction of the connectivity between the ISPs. Here we have ISP-A and ISP-B. That essentially means this connection over here, this path. But whenever a large audience comes by, of course, this link becomes a problem. You have an interface here that is essentially this interface in this diagram that starts to become congested, either because your audience is the cause, or maybe just somebody else's audience that has anything to do with you, but is impacting your quality of experience for your audience. And because at the end of the day, all are sharing the same interface, the same links, the same internet exchange points, for example, between those ISPs. So what happens, of course, whenever this is in place, the experience of anybody downstream start to have an issue. They start to see a degradation of the quality of experience in terms of bit rates or even rebuffering. And again, it doesn't matter if it's a last mile end user device or if it's even a POP in a CDN. If you don't get the content right, you are not going to deliver the content downwards, either to the end user eyes or to the next device down the pipe. Okay, that is on a high level what's going on. And for those that attended the last week call, this is actually the same, but now we're going to get a little bit deeper on what's actually happening under the hood, because this is still a more or less high-level example of, or high-level abstraction of what's going on under the hood. Let's go deeper to see what is actually happening under the hood. This is an internet map that we created in-house in System 73 using information that is publicly available about how the internet organizations connect to each other. And that's information that we collected and we processed in order to actually understand what was going on and have a better visibility. But just to give you a glimpse of the relevance of this problem and the complexity about it, I want to highlight that each and every node in this map, for example, this large number here with the smaller numbers below and other ones here until you are not able to actually see the numbers inside the chart, each and every number that has a circle associated with that is an autonomous system. An autonomous system is just an abstraction of an organization that operates on the internet. So under that number, there is an organization, for example, an ISP, and you may have below that number and that small circle, undetermined number of router and public IP addresses. Imagine these guys can be, for example, a large ISP, AT&T, Verizon, Vodafone, you name it. It's going to be a huge number of devices and routers and public IP addresses just abstracted with one single circle. And all the connections between the different circles, they represent the peering agreement, again, the word peer, about different organizations between each other. Of course, in order to send the traffic over the open internet, you need to have peering agreements with other organizations to make the content flow between your infrastructure and the next guy's infrastructure. So each and every more or less transparent link here, because there are so many that cannot be shown precisely, are the links, the abstraction of the peering between those organizations. You can imagine this is a whole internet map, and if you want to make sense of this from a human perspective, it's completely overwhelming. Going back to the previous chart, what we have just mentioned here with a toy example, that is, let's say, this first bubble over here, the ASP-A, this is the equivalent to one circle And it can be this small guy over here, right? The small green dot over here. And below that, of course, you will not have only 3 guys. You're going to have a huge amount of routers, devices, and routes associated with them. So making sense of this and making sense of this in real time to solve the problem is something that is quite overwhelming from a human to do. It's not just a matter of saying, I go to CDN A, B, or C and call it a day. No, we need to do something more intelligent than that. So let's go a little bit deeper about what is the root cause of this and what we can do about it. Okay. So keep in mind, this is just an abstraction of the internet infrastructure. Nowadays, every circle is an organization, and you need to traverse those organizations to make your content arrive in time into your audience. What happens under the hood is that we have an infrastructure that is somewhat outdated in the form of how they chose the best route to deliver the content from one point to another. The open internet, because it's open, there are some protocols that are in charge of making the selection of the best route for making the content flow from one place to another, but nobody has full control of how that routing works, because at the end of the day, if somebody controls it, essentially, there is no internet. It will be just the net of somebody. But what means at the end of the day is that in order to solve that problem, people try to patch it somehow. For example, adding more hardware to the problem. For example, adding more CDNs to the delivery effort, just in a hope of having more capacity. But the problems may not be on the CDN capacity, may be on the peering points between the origin and the CDN, or between the CDN and the last mile, or anywhere in between. And that connectivity that we have shown here, this is a static map, but this map changes within milliseconds. There are changes in routes, there are changes in configurations by ISPs, there are changes in peering agreements, and you cannot just have a personnel on top looking at that with their eyes peeled. And even if you add more hardware to the problem, at the end of the day, you're just consuming a lot of resources in terms of energy, cost, and time to solve a problem that is not solvable that way. Because the industry is tending to more and more data and more dynamic changes of the route to have that data arrive in due time. If we're going to talk about 4K, 8K, and not only talking about streaming VR or ER, that requires between 10 and 100 times more content, more data to be delivered in due time. So this is a compounding problem. Unless we find a solution for that is flexible and automated as far as we can, we would not be able to solve this problem. Okay, let's go a little bit deeper on why these problems have not been solved, okay? This is when we start to divert from the previous talk, and we're going to go a little bit more technical details on what was going on the open internet. BGP, Border Gateway Protocol, is the protocol in charge of routing the content through the open internet whenever the content leaves the organization's hands into somebody else's, right? The goal of that protocol comes from the fact that you wanted to minimize the number of hops, so essentially the number of routers that you need to traverse to go from A to B, okay? That's fine whenever there is no congestion in the network, like an example here on this toy 4 users scenario. So you have the 4 users here below, and you want to reach the content that is upstream, okay? Okay, so BGP in this case will say in a very much higher level abstraction than the reality that we're showing here. You need to traverse the least number of hops to find the content. In this case, okay, you have 3 nodes, 3 routers from the right side, and then 2 routers from the left side. Okay, so the best route will be traversing those 2 routers. Fine, fair enough, everything is good. Whenever you have a larger audience come by, what happens is the scenario here below. You have those 8 same nodes receiving the content from the same route, because it's still the fastest in terms of hops, instead of in the approach of how many routers you need to traverse to get the content. So here, even if the branch on the right is underutilized, still BGP is going to take you through the shortest path that actually is the slowest in terms of performance, because congestion is not taken into account into the Border Gateway Protocol. This is a very well-known issue, but it's also a governance issue, because whoever controls the internet capacity will be able to change that, whatever they do. So it's a chicken and egg problem, right? We need to find a smart solution to this rather than just banging our heads to the fact that the internet was built that way. And of course, the outcome is that the quality of the content degrades. So, okay, we need to find a solution for that. In the big picture, if you collect all this information associated with the scenario that we mentioned before, that tree that we mentioned before, that it was a simplified case, this is a little bit deeper. Every circle here represents one of those autonomous systems. So for example, this is a circle about ISP A that is in charge of providing services to, say, a CDN. And then this is a last mile ISP that is providing services to end user, your audience, okay? And of course, you will have multiple ISPs and you may have potentially multiple CDNs, okay? What happens with the example that I mentioned before is that, okay, some areas of the network may be working fine, like this here, but some of them may be congested. And it can be congested first on the last mile. That is a straightforward scenario to be understood. You have a lot of people congesting the network that is in charge of delivering the content for one specific ISP on your last mile. And of course, that is a degradation. But it can also happen because many ISPs are actually putting a lot of strain on point of presence in one specific geographical region. So here, for example, you have the nodes that are part of the CDN, so points of presence, already saturated because they cannot receive the content correctly from the origin, because this link here that is within the CDN infrastructure is also congested. And here we have a slightly different scenario where the problem in the CDN is not there, but you still have a congestion on the last mile because the ISP is limited in capabilities. So here, even if you throw out more CDN capacity, you're not going to solve this problem. You need to find a different solution. And here, even if you have more iron to the problem, more capacity, at the end, you're going to reach the ceiling of the capacity of the CDN that is being deployed. And if you want to go over that, you need to find a different solution, right? So a change in strategy is needed in order to solve this problem. Now let's go into that, how to make that happen. So in order to solve that problem, we come to the realization that you need to have, first of all, real-time visibility, like we have just mentioned here in this diagram, but of course, in reality, with the actual information flowing in order to solve this problem. And not only that, you need to have the visibility just to get the information about what is the right choice of that route, and also have the mechanism to change that routes in real time. Otherwise, you are essentially too late to do these changes. And if you don't do that, you will inevitably have congestion on your delivery chain. And that, of course, is going to happen as it's going to surface as a quality of experience problem, and at the end of the day, churn, so loss of retention on your audience, independently of the business model that you run, ABOT, SBOT, you name it. You will have, at the end of the day, an impact on the quality of experience. And for live streaming is even much more important. So one thing that you need to do is to purge the data that is not applicable for your problem, because essentially you have constraints upstream and you need to solve for that. And whenever you have the right information, you have to optimize the network topology to make the problem tractable first, and then with that, you find the solution. So let's talk about how that is built and how that is doable, okay? In the previous scenario that we were talking before, this 8 scenario, the 8 user scenario, when you have these guys here, even in the last mile, congested this link, there is a way to make this happen in a more effective manner. If you have already computational capacity inside the ISP infrastructure, for example, end user devices that are able to relay content, you are able to leverage them in order to make this congestion disappear from the delivery chain. Let's say, for example, that is an end user that is connected through cable, through fiber, that it has no capacity to relay content to somebody else, of course, with all the correct countermeasurements to not overuse that upstream capacity, keeping the quality of experience top-notch, and complying with all the bells and whistles that are required to make something like this happen. You can make the content relaying inside the ISP here without congesting the links upstream. This is something that we do with end user devices, but it's also something that we do with the devices that are upstream. And it's something that, as it ties with the first principles of what is a properly built tree of nodes in the delivery chain, that is applicable for anybody. Even if we provide that service through our portfolio of services in Systems 33, this talk is applicable to anybody that wants to solve this problem, okay? But of course, in order to do that correctly, you need to be very, very smart about the data collection and also the actuation on that information. You need to have real-time monitoring. Okay, we're going to talk a little bit about how we collect that information. We need to automate the actions based on that information collection, and you need to be dynamic in order to forecast an impact on the congestion before the quality of experience impact happens. Okay, let's go a little bit deeper into this. Information is what you need. Data for the sake of data is not going to help you. Actually, quite the opposite. Let's go back to the scenario where we mentioned before, where you have all this internet map. The data is already overwhelming from a static standpoint. Imagine this dynamically. You may be swamped on data. If you start just looking at dashboard, for example, for the sake of trying to make sense of what's going on, you can be easily overwhelmed, trying to find a needle on the head and not finding the actual root cause of the problem. Because you need to find the right data. It's not just data for the sake of data. You need to have the right data that becomes information that enables you to make something actionable about your problem. Okay. So at the end of the day, you need to select the right data to make it information that is actionable, and the right data is going to enable you to solve the problem. First of all, quality of experience data is something that you need. That you need to have something that is related to your use case, to your streaming content, to your streaming event. You need to have data that is related to the quality of experience of your own audience in real time. It doesn't matter if you have data from the infrastructure as a whole, from the community, maybe people that is served by the same CDN, it may or may not relate with you. For example, maybe you are interested in having top quality video renditions in a normal latency scenario, but maybe you are on the opposite side of the spectrum. You are able to sacrifice a little bit of quality in terms of renditions and bit rates, but you have a lower latency restriction, right? The challenges that are applicable to each of those problems are different, and your audience is different, and your retention capability based on the quality of experience tolerance is different. So you need to have data from your own audience. It doesn't work if you have from somebody else's. And not only that, you need not only quality of experience data on the last mile capture on the device, but also about the visibility of the whole entire delivery chain. Like we just mentioned on the slides before, you need to have visibility of the whole delivery chain through multiple hubs. Otherwise, you will not be able to find what is the bottleneck, what is the congestion point, and how to avoid it. And of course, to avoid it successfully, that means avoiding the congestion areas without having an impact on the quality of experience, you need to automate this. You need to make this change dynamically based on the data that you have. So you're actually forecasting what is going to happen to your audience before the quality of experience gets degraded. Okay, you need to see that information both at the quality of experience and at the network level. Okay, so how to collect that data to make it information that is actionable? As I mentioned, quality of experience data, like any other analytics provider, the usual method is through an SDK that is running on your audience and user devices, either web page through a JavaScript code, or in the native applications with the flavor of choice of the language of that native platform. You have the SDK and you collect information. You can do it with us. Of course, this is also part of the marketing speech, but it doesn't matter. You need to have the information. You can do it yourself if you are able to do that, but of course you can benefit from the economy of scale just using a provider for getting this information. Whenever you get the quality of experience data and you do it the right way, you have the quality of experience, but also the network performance about that last mile and also the connections between them, you start to see that visibility. Okay, this is assuming that everything is static, but everything is dynamic in reality. That high-level internet map that I just shared changes, and it changes in milliseconds, right? So you need to have very fine-grained granularity in the time that you collect information about to make it properly actionable before the quality of experience impact happens. From our experience, we need to have data at least every second, because the buffer health of the players, essentially the amount of buffer that the video players hold locally to compensate for any issues on the delivery chain, is usually a matter of seconds. Normal latency scenario, maybe you have 20, 30 seconds of buffer if everything goes well. Most of the time you go below 15, sometimes 10 seconds. If we are talking about low latency, we're even lower, 5 seconds or even less. So if you have granularity sampling of that performance data every minute or even every 5 seconds, whatever happens between those minutes, 5 seconds, is going to be a blank space for you and for your systems to see what's going on. And of course, if you are blind, you cannot make the proper actions. So you need to have fine granularity data every second at a minimum. And whenever you have that visibility, you need to have the visibility not only of the last mile, so the end user device, but also visibility upstream from each and every hop that you track, because you need to find the root cause of your problem and then avoid it and switch it to somebody else. And not only switching CDN providers, because it's only 1, 2, or 3. Here, the problem is much more complex than that. You need to reroute the whole traffic to the right places, okay? So you need to have visibility about the network performance, including the last mile, but also between the end user devices themselves, if you leverage them to scale, and also the connections toward the CDN points of presence and upstream, okay? So let's see how we do that. We are going to talk about how to build it with the first principles approach, so a broadcasting tree, but we want to touch upon why traditional approaches on the open internet, when you have multiple data paths on your hands, is something that from our experience is not recommended. Because at the end of the day, we have just mentioned that the viability of the content is flowing through a traditional fan-out architecture. You want to have the content going from one origin into multiple destinations. And it's by nature a fan-out architecture, right? A fan-out topology that goes from one source or a couple of them and then into multiple endpoints through different jumps. That by nature is a tree, right? It's a broadcasting tree, like we have discussed it with the terrestrial cable and satellite. It's the same scenario. So whatever you do outside of that needs to be justified if that's the case. But from our experience, even in this toy example, you have still 5 nodes here with a single CDN provider. If you connect them between each other in a mesh fashion, like everybody connected to everybody, what you get is initially a sense of high redundancy in case some of the links fail, but if you are doing the things right, that means that you are able to detect where the problem is and you are able to change it. You don't need this, because this is going to create a lot of overhead in terms of efficiency of the network, because you need to send the data from multiple paths in order to have that fake feeling of redundancy. But not only that, you're also introducing overheads instead of in the sense of time, because you need to orchestrate or just discover where the content is available, where the content is coming from multiple sources. While you have a single one that is the right one, that is going to drive you the higher level of benefits. And of course, if you do it the right way, you are going to achieve better quality of experience performance. Otherwise, you are getting the minimum common denominator of all the links that you have upstream, because you cannot aggregate them together, right? So another difference, if you don't do it this way and you do it in a traditional fashion, wherever everybody's connected to the CDN, of course, in this scenario that we just mentioned before, but here in a very, very clear fashion, exactly the same 5 nodes, right? 5 nodes directly connected to a source, that in this case is a CDN, but it can be an origin server, the same applies. Is going to congest the interface between that CDN and the nodes below. But if you do it correctly, again, with only 5 nodes, if you're able to leverage that capacity, you're going to increase the efficiency, increase the performance, and by the way, also increase the financial efficiency of your delivery, so reducing your cost in terms of operations. And if you automate it, you're going to reduce also your capital expenses in terms of over-provisioning and human resources to monitor this. Okay, what is the actual outcome that we want to achieve by doing something like this? Is going from this spray and pray scenario where you just deliver the content and hope for the best into something that is top-notch quality, trying to achieve the highest quality that is available to be perceived by any end user device, avoiding congestion through the delivery path. Okay, that's the holy grail objective of all of that. But at the end of the day, it's just moving the quality higher into the highest level of performance that we can achieve. And the outcome of this is actual production data of what you can achieve if you do something like this is, of course, most of the people watching the highest quality that is available on that specific stream. Here in this example, the bitrate ladder goes all the way from 480 into 1080p. 94% of the audience was watching the 1080p rendition. Of course, this is a cherry pick scenario to showcase this trend, but that's something that is actually coming from production and is actual data that is reflective of what can be done. We're going to show a little bit later some actual production data of how that is built and how that's related with our previous talks. But first of all, I want to mention that in this case, 78% of the traffic is being delivered through the peer-to-peer network like we built with the tree. And that is actually a direct correlation with the efficiency of the network and the quality of experience increase. So how that is happening, we're going to start again with a toy example just to understand what's going on under the hood. Here is a 50 node scenario, still small, okay? So every circle that you see here is one of those end user devices that are connected to each other, and ultimately they're connected outwards to the CDN. And this resembles a scenario where you get the content coming by in terms of audience, and they join your event, and you have the traditional organic increase of the audience into your analytics curves. And what is different here is that we are able to showcase that if you arrange it correctly, even in real time when the audience is coming by, you see a decrease of the load on the infrastructure that is shown with the blue curve, because it's the load that is happening on the highest area of the broadcasting tree. That is the usually more expensive area of the network, because the higher that you go upwards, more expensive it is for you for scaling that area of the network. So here we can see that the load is decreased by the correct arrangement of the tree. And then at the end of the day, we reach a very good ratio of content being delivered through the P2P network and making it very stable. Again, scenarios that are related with this, but with a little bit more realistic volumes. We're going to see here how that extends. Again, using the visualization methods of a top-down tree. 8 viewers, like we just mentioned before, toy example, but this is how it propagates to actual production data. So 240 viewers, 1,050 viewers, and these are still very small numbers. We can go all the way into hundreds of thousands of concurrent viewers, but then you will not be able to see the dots actually. So what you will see is essentially a very, very fuzzed scenario like the one that we just mentioned before on the internet map. This is the way to make this happen. For example, here we have flagged out some details in the tree, wherever we flag that some of the end users are not having a good connection, or some of the points of presence of the network are not behaving correctly. And that means that this specific snapshot in time, that is just 1 single second of data from the whole infrastructure, is telling us that, okay, we need to rearrange this guy over here, and we need to put it somewhere else. And this guy over here, we should not touch because it's not behaving correctly. All of that being collected in real time to our backend systems, and then rearranging the network topology in real time in the middle of the session without any impact whatsoever for the end user devices. So it's transparent for them. It's like multi-CDN selection, but actually solving the problem with steroids, actually solving the whole delivery chain from the get-go. You can see here in this more realistic scenario, whenever we see a large area of the tree here below, that is a subtree that we have detected that is the best area to be connected with, because we have detected that some other areas of the network are congested and we shouldn't use it. And this behaves completely naturally, organically, without somebody monitoring with a NOC, a network operations center, with people just moving knobs with the hope of fixing the internet. That is impossible to be done with human resources on the loop. This needs to be fully automated and in real time. Okay. Just to recap a little bit about what's being covered here. Of course, this unlocks a new set of possibilities whenever you have visibility of the quality of experience data of your own audience and your own streaming services, not relying on community data, and you have visibility of the network capacities of the end-time delivery path, including the last and the middle mile. You will be able to have accurate quality of experience and performance data, and it will enable you to implement automation and achieve optimization of the delivery chain. If you want to use us, that's great. If you want to implement it yourself, that's also a possibility. It's up to you. But we wanted to share you with our customer base and also the market what we have understood and learned over all these years of working in the industry. Okay, so without further ado, I think it's worth it to go into the Q&A section. And we're going to show you, again, the QR in case that you want to request a meeting with us in IBC next week, or if you want to just reach out for something else, just do not hesitate to contact us. We have also the QR available for that. So just let us know if you would like to have more information, or just drop your question on the Q&A panel, and we'll be happy to answer during the Q&A. We still have around 15 minutes available, and we're going to cover several questions that have come in on the board. So I have a question that goes along the ways about if can your analytics solution determine where all the network issues are occurring? As I just mentioned, what we see is the whole delivery chain. We're able to pinpoint wherever the source of the problem is. And through the analytics solution, of course, it comes naturally for us as the fact that we need to process that data to show it to the internal systems that manage the orchestration of the network connectivity is straightforward for us to surface that data into our dashboards. So we're able to showcase that through our analytics solutions too. Even if you're only interested on the analytics side of it, that will be available through our panels. Okay, there's another question, says, you talked about community data. What does that mean? What data does System 73 use? Okay, that's a very good question. So some parts of the industry, as I mentioned, tries to solve this problem, adding more CDNs to the mix, assuming that the data that they've received either internally or from external providers is telling that the CDN A is not behaving correctly and they need to switch to CDN B or C, right? But most of the time, this data comes from providers of CDN performance that is showing just that some area of the geography served for one CDN is not performing as well as the very next guy. But the problem here is that the data is shared by people that is willing to participate in the community sharing and may have something to do with your use case. For example, may not be related with streaming whatsoever, maybe just related with video game downloads or updates or gifts or whatever, and may not be related with the actual performance that you get into your audience. And the difference from what should be done and actually what we do is that we collect the information directly from the end user's device's video experience that is very, very related with the use case that you have in terms of infrastructure, content, protocols, you name it. Okay, more questions. So how do you determine when to switch CDNs? Is there downtime needed to make this happen? No, there's no downtime needed. We do the switching in the middle of the session. And by the way, it's not just between CDNs, as I mentioned, it's through the whole tree. It may be related to connect you to somebody else inside your network or somebody else between you and the same ISP or a different ISP. All this tree is completely agnostic of what kind of content are you using and what CD infrastructure that you have. But yes, the switch is happening in real time in the middle of the session. This is really, really important if you want to keep the quality of experience top-notch whenever the performance of the network changes with the actual audience, either yours or somebody else's. If you see an increase of people joining to your content or some infrastructure issue is happening on the area of the network that you do not control, you need to be able to switch everybody else to the right place into the timeframes that are within seconds without requiring to reload the video stream. So we do the switching in real time. In the middle of the session, no need to do anything from the end user side. This is the holy grail solution for this kind of problem. Okay, more questions coming in. So we have, okay, how easy it is to get up and running with your team service. We have had customers integrating the SDK in 1 hour, quite frankly. Of course, this is the cherry picking scenario. Usually the timeframes are just related with your capability to involve your team to do the integration, but integration is just one single line of code, either in JavaScript for web or the native flavor of language for your platforms in native devices. It doesn't have any difference from any other analytics provider in that regard. And if you are used to use analytics providers, it's exactly the same approach. The only difference is that we're able to not only surface the analytics, but also showcase you that the problem is here and then automate the changes if you want. Okay, I have questions over here. Does this involve installing an SDK on the client devices? Yes, as I mentioned, it's nothing different from any other kind of arrangement in that regard. In our case, we engage with your audience through an SDK. It's just one line of code, and that allows us to collect the information that is needed and to do the switching accordingly. Okay, another question coming in, how much delay will your system introduce? That's a very good question. And I'm going to go back to the tree to showcase here a very interesting phenomena that happens with this. So here you can see that in a large scale scenario, not even so large scale, but it's actually 1,000, more than 1,000 users. You have a couple of hops in the delivery chain that may be around 13 here in this case. But we do not wait for the content to be complete on every hop to deliver the content. That allows us to not introduce delay in terms of latency. We only have the milliseconds that are available between each hop. That is usually completely negligible in terms of delivery chain from the origin to the destination. But we do that in a chunk and transfer encoding method. So that means that if you have a video segment, for example, 6 seconds traditionally on HLS or Dash, we don't need to wait for the whole 6 seconds to be available here to jump to the very next guy. Or in this toy example, to be available here to jump to the very next guy. This is a huge difference from traditional CDN platforms, wherever you actually need to have the full segment cached before it can be transferred to the next guy. Whenever we have the very first chunk of content that is usually 16 kilobytes in the first node, we deliver it right away to the next one. That allows us to traverse the whole tree without waiting to have the single segment available. So that means that we only have a couple hundred milliseconds of jumps between them, and that is usually negligible in the scenario that we're talking about of live streaming at scale. Okay, more questions coming by. Let me check the time. Yes, we have still 9 minutes. So I'm going to cover a couple of them more. Essentially, if I understand correctly, thanks to this technology, the more people that are live watching my stream, the better the content is delivered. Is that correct? Yes, that's correct. One thing that is counterintuitive here from what we do or what can be done with these kind of technologies, specifically if you leverage the end user devices, is that the larger your audience, the larger your capacity. For example, you may think, okay, Daniel, if I use the end user devices, not everybody will be able to relay content, right? The usual connections are asymmetric. You have usually more download than upload. And not only that, you also have cellular connections or connections that are metered and you don't want to use them to relay content. That's correct. Fair enough. And the solution here is, again, the tree. If you know that you are on the cellular connection, you usually want to avoid to use them for relaying content, because the computational device is small and you don't have a very good connectivity and it's a metered connection. So we by default detect and avoid those end user devices to relay content. And we allocate them on the bottom of the tree. And you can see here that just by the nature of the tree, because it grows exponentially with the audience, we have a very large surface on the bottom of the tree to allocate devices that are not capable or not eligible to relay content to anybody else. They still get the benefit of the improved quality of experience and availability of the content because they are still participating on the P2P network, but they are not required to relay content because either their upstream is not good enough or their connection characteristics are not allowing them to participate, or they are just opting out from that because we don't want to use them. It's up to the integrator of the customer, in this case, you guys, to choose. But we do that fully automatically. We by default detect cellular connections and we detect how much is the remaining upstream capacity. We always keep safe margins to never overuse and always keep room of usage on the uplink. So everything like this works correctly. It's a requirement for us to do so, because if we do not monitor in real time the network capacity on any of those end user devices in the uplink side, of course, also on the downlink, but the uplink is critical, you will not be able to maintain this tree. The tree collapses, essentially. It's like traditional infrastructure at the end of the day. Everything based on first principles is the good thing that the solution is very easy and similar to everybody. Doesn't matter if it's end user devices, if it's fixed devices on a contractor infrastructure, or if it's a third-party provider, the problem in first principles is the same. Okay, and by the way, here the exponential nature of the tree means that the larger the audience that you have, the larger the capacity expansion and the capacity of absorbing more people comes in. And that means that you are not limited anymore by the currently available infrastructure on your geographic audience of choice. So you can avoid those bottlenecks and expand on top of that. That is completely opposite from the solutions that are traditionally deployed for this. Ultimately, you hit the limit of the infrastructure if you do it that way. Okay, more questions. How can all this information be used to automate the routing of the traffic? Very good question. For example, as I mentioned here, if we know that this area of the network is congested and we know it in real time, and we know also from the past what was the capacity that was available there, we know all what we need to decide, okay, I'm not going to load more this area of the network, or even further, I'm going to remove end users from that path in order to become green again and become healthy again. And that way allows us to automate these changes. We have a backend system that collects this information in real time at scale, elastically, and communicates directly with the end user devices through the SDK to say, hey, please change your path to this route that we know is capable of allocating you in timely manner. Okay, more questions that comes by in the Q&A panel. Are there any upfront onboarding costs? Do you have a minimum commitment? No, you can join us in a free pay-as-you-go model, so no upfront commitments. And by the way, in IBC, we're going to announce, but it's essentially a premiere that I give you guys. We're going to announce the fact that we are going to offer the basic analytics tier for free. So you're able to integrate our SDK for free and see the information with no strings attached, no limitations, no commitments. And if you like what you see, we're happy to talk. And the next question, and I believe it's going to be the last, given the time that we have, how much time is required in advance in order to scale up your P2P network for large live events? Very good question. Actually, our infrastructure is designed to be elastically scalable. So as you may be aware, we don't need to deliver the content ourselves, in the sense that we don't need to put infrastructure to grow with the audience. So for us, for Systems 33, our backend systems, they need to only orchestrate the routing paths, and that reduces a lot of the strain in the load. But of course, we need to scale with the audience, and we have our infrastructure built that way. So there's no upfront in terms of allocation for the scalability of the P2P network. Whenever you have a large event, the systems detect automatically that you have a growing audience coming by, and the nature of the expansion of the network absorbs the load, and we on our backend systems are in charge of everything else without having to worry about the scale. And I think, oh, we have a couple of more questions. Let me try to tackle that. Okay. If I understand correctly, the solution does change the routing path based on congestion. How is this managed when there is a VPN in the mix? Very good question, actually. We have scenarios like this in our current customer base that they operate for corporate events. So they have that kind of issue, and it's not only that issue, but also compounding with the effect that if they have a large organization within a company and everybody tries to use the VPN and then go out into the open internet from the same funnel, it's exactly the same problem like I mentioned before. So here, for example, we can use this example that you have here a large audience here, and then this is the bottleneck, that is the output pipe of the VPN. And the solution for that is that we are able to detect what kind of network infrastructure is in place. So we can decide to prioritize connections within the local area network, or traverse the open internet if it's chosen. And that way we're able to comply with these kind of requirements. The good thing is that the solution is the same, independently if there is a VPN or not. But the good thing is that the connections are routed through the right place. So customers of ours, like corporate events online, they are happy to be used as a referral account for us. They work with the 500 Forbes list companies in the US for running the townhouse calls for their internal employees, and they use our technologies nowadays. And actually, they are fully integrated with their platform through the SDKs and the APIs. So we are familiar with that scenario, and the good thing is that as we approach this in a first principle approach, the solution is applicable for anybody. Okay, I think we have reached the bottom of the slot. Again, I want to thank you guys for your time, and you will have also the possibility to reach out to us, as like I mentioned, through this QR code if you want to schedule a call